In this video, we will look at a question where we need to draw the profile of a cam. So the question is draw the profile of a cam operating a knife edge follower. So the type of follower is knife edge follower having a lift of 30 mm. So the total maximum lift of the follower is 30 mm. The cam raises the follower with simple harmonic motion. So the motion of the follower when it raises from the lowest to the highest position is with simple harmonic motion, and for it is for 150 degrees of rotation of the cam. It means when the cam rotates for 150 degrees, the follower must rise from the lowest to the maximum height of 30 mm. So during the first 150 degrees of rotation of the cam, the follower must rise a height of 30 mm with simple harmonic motion, followed by a period of dwell. Once it rises to the top, it has to stay there for 60 degrees rotation of the cam. After 150 degrees, when the cam reaches the highest position, then for the next 60 degrees rotation of the cam, the follower must stay on the top. Next, after that, the follower descends. Descends means it will come down now. From the top position, it will come down. So for the next 100 degrees rotation of the cam. So for the next 100 degrees when the cam rotates, the follower must come down with a uniform velocity. Now when it has to come down, it has to come down with a uniform velocity, followed by a dwell period. Then again, when it comes down, it has to stay at the lowest position for some period. That he has not given how much. So he has given the angle of ascent, then he has given the angle of dwell or delta 1, and then he has given the phi a, this is delta 1, and this is phi d, this is the angle of descent. Delta 2 we have to calculate, so 360 minus these three angles is delta 2. The cam rotates with a uniform velocity of 120 rpm. So speed of rotation of the cam is 120 rpm and has a least radius of 20 mm. So this is the base circle radius. What will be the maximum velocity and acceleration of the follower during lift and return? And also we have to calculate what is the maximum velocity and acceleration during lift and also return. Now you see here he has given all these values. Height is equal to 30 mm, angle of ascent is 150 degrees, angle of dwell at the top, that is delta 1, is 60 degrees, angle of descent is 100 degrees, base circle radius is 20 mm, and n is 120 rpm. This is the rotation speed of the cam. Now the second dwell angle is 360 minus phi a minus delta 1 minus phi d. So if you do that, it will come to 50 degrees. So if you add all these, phi a, delta 1, phi d and delta 2, it will come to 360 degrees. Okay, so these are the values given. Now we have to draw the displacement diagram first. So the ascent is with simple harmonic motion, and descent is with constant velocity. So okay, first we will draw the displacement of the motion, displacement diagram of the follower. After you draw the displacement diagram, then we will draw the profile of the cam. So it's always whenever you want to draw the profile of the cam, first you have to draw the displacement diagram. So now we will draw the displacement diagram. Now we have height is equal to 30 mm. So we will take a scale. 1 centimeter is equal to 5 mm. So this scale is arbitrary, you can take whatever scale you want, but if you take a large ratio, the diagram will become very large. If you do as it is, 30 mm means the height will be 3 centimeters. The height of the displacement diagram or rectangle will be 3 centimeters. That would be too small. So I have doubled it. So if we take 1 centimeter is equal to 5 mm, then 30 mm is represented as 6 centimeters. This is for the y-axis. Now for drawing the cam rotation on the x-axis, no scaling is required. You can take whatever length you want, it doesn't matter. Okay, so the scaling has to be applied only for the y-axis. For the x-axis, there is no scaling required. You can take whatever length, convenient length you want. So that is the point you have to remember while drawing taking the scale. It's only for y axis and it's not required for x axis or cam rotation. Okay, now we'll draw a height of let us say 6 centimeters. uh, Start from here to 1 2 3 4 5 6. Okay, so let us say this is a height of 6 centimeters. And the length can be any arbitrary length, it doesn't matter. Okay, now we have one side of the rectangle. Now you draw a rectangle here. See, as shown in the here figure, you draw a rectangle. The height must be 6 centimeters. This height. This length can be whatever you want. You can take any length you want. Okay. Now afterwards you draw taking at 3 centimeters of the height. You take 3 centimeter radius and draw a circle like this. Okay. And this is for simple harmonic motion of the follower during the rise. Okay, so in the problem he has given that for 150 degrees the follower rises with simple harmonic motion. So after you draw this semicircle, you mark the center and draw this line. Now divide the semicircle into, let us say, 6 parts. Okay, so here we have the semicircle. Now we will divide it into 6 parts. So you have to do it, you have to do all this drawing in the using the drafter on a drawing sheet. Okay, here we are just doing a rough diagram, so just to show you. So it's difficult to draw here, but while you draw you have to use the drafter, mini drafter, and drawing sheet. Okay. Okay, once you have drawn this, divide it into 6 equal parts. Now what you do is you divide the x-axis also, starting from this point. Mark this point as 0. Okay, this point is 0. Now from this point you divide this x-axis into 6 uh, 6 parts. Okay, because you have divided the semicircle into 6 parts, so you have to divide this also, the x-axis also, into now 6 parts. 1 2 3 4 5 and 6 parts. Okay, now draw, and after dividing it into 6 parts you draw vertical lines like this. 1. So you have to practice this using mini drafter and drawing sheet. If you don't practice this, then you cannot do using rough work. Okay, so you do practice it in your drawing sheet. Here I am doing it as a rough diagram, but you have to do it with the drafter. Okay, now when you have marked and divided the length into some, you take some distance, let us say 1 centimeter. So after from 0 you take 1 centimeter and mark 1.1, then 0.2, 0.3, 0.4, 0.5 and 0.6. So the distance between these lines can be 1 centimeters. Okay, so I told you that on the x-axis there is no scaling, so you can take whatever distance you want. If you want, you can take half centimeter also. Better you take it as 1 centimeter. It will look better. Okay, and now you mark the same numbers on the semicircle also. So 0, after 0, 1, 2, 3, 4, 5 and 6. Okay, now from the point 1, you draw a line up to the first line. Okay, then from point 2 draw a line up to the second. Then from point 3 draw a line up to the third. Then from point 4 draw a line up to fourth. Then from point 5 draw a line up to the fifth line. Okay, of course from this from the sixth point onwards, if you draw a line, it will automatically come and meet here. Now once you have got these points, you join them using a smooth curve. Okay, so the curve must be like this. Now after that you mark this. See, from this point 1, now where it has cut the vertical line, there you mark 1 dash. This is 1 dash, and this is 2 dash, and this is 3 dash, this is 4 dash, this is 5 dash, and of course this is 6 dash. Okay, so this is the ascent, or from here to here, this is the angle phi A, that is equal to 150 degrees. So ascent is with simple harmonic motion. So we have to draw it according to the simple harmonic motion. Now leave some gap. This is the dwell at the top position. Okay, so let us say here this is delta 1 up to here. You take any arbitrary length, you can take 2 centimeters, 3 centimeters or 4 centimeters or whatever it is. So I told you there is no need to have any scale in the x direction. So the delta 1 value is given as 60 degrees. So you mark some length, it's okay. Okay, so now you mark this point also as 6. This point is also 6. So this will also become 6 dash. See, so 6 to 6 dash, whatever height is there, the same height will be here, 6 to 6 dash. Now what he has told, the follower decreases or returns with constant velocity, and we have learned how to draw constant velocity also, so it's very easy actually. So again mark this divide this into 6 equal parts. 2 1 2 3 4 5 6. Once you mark it into 6 parts, again now draw the vertical lines. So 1, 2, 3, third line. So actually we have divided into 2 divisions. Now this is the third division. So it's difficult to draw here. So you, while drawing on the drawing sheet, it will be easier. So don't forget to practice on a drawing sheet using your drafter. Okay, now we have divided it into 6 parts. Now from 6 you start the numbering 7, 8, 9, 10, 11 and 12. Okay, now for constant velocity we know that you have to just join the opposite corners here like this of this it's getting difficult here. Okay, so just join the opposite sides. Now here we have 7, so mark this point as 7 dash. This is 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and of course 12 and 12 dash will coincide. 12 and 12 dash are on the same point. So that is the end of the displacement diagram, and this angle is he has told that this angle is around what is the descent angle? It's 100 degrees. Okay, phi d is equal to 100 degrees. Okay, so this the remaining will be the again the remaining part will be the this is delta 2, let us say that is equal to 50 degrees. Okay, so this is the total displacement diagram of the for this given problem. Okay, so here we have taken height, this height as h is equal to 30 mm. By taking a scale of 1 centimeter is equal to 5 mm, we have taken 30 mm is equal to 6 centimeters. So this height is 6 centimeters, and then using 3 centimeters as radius, draw this semicircle. Then you draw complete a rectangle of any arbitrary length. Don't complete the, okay, you just draw the rectangle like this. You keep this side open if you want. Now divide this semicircle into 6 equal parts, and on the x-axis also you divide into 6 equal intervals. So this interval gap may be 1 centimeter. Okay, so on the x-axis it doesn't matter how much you take. So but whatever you take same. If you take 1 centimeter here, this also should be 1 centimeter. Again 1 1 1, so you take it as 1 centimeters. Okay, then from point you mark these points as 0 1 2 3 up to 6, and these points also on the semicircle as 0 to 6. Then from 1 you draw a line until it intersects with this vertical line 1. Then from this point 2 you draw another horizontal line until it intersects this vertical line 2. Call this point as 2 dash, and this is 1 dash. Then from 3 you draw another horizontal line and until it intersects the vertical line 3, and that point of intersection is 3 dash. Similarly from 4 you get 4 dash, from 5 you get 5 dash, from 6 you get 6 dash. If you join these lines, you will get the curve. Smooth, you draw with a smooth curve, you join these lines. So this is the rise of the follower with simple harmonic motion for 150 degrees. Next we have a dwell. Take some arbitrary distance and then draw another line. Mark this point also as 6. See, that is very important. When you end here with 6, start again with 6. So this is 6 and this will be 6 dash. Now again divide it into 6 equal parts. Then again for each part you draw a vertical line here, equally spaced, let us say 1 centimeter apart. Then join the diagonal, because this is a constant velocity descent. So for the constant velocity, this is the method. Okay, you divide into 6 equal parts. The parts you divide here or the circle must be even always. Either divide it into 6 equal parts or 8 equal parts. So dividing into 6 equal parts is enough. So we will always divide this into 6 equal parts. Now once you join the diagonal, we have this line intersecting at this line 7 at here. So this is 7 dash. Similarly, this will be 8 dash, 9 dash, 10 dash, and 11 dash, and this will be 12 dash. So this is the displacement diagram. So this diagram we will again use while drawing the cam profile. Okay, so that we will do it in the second part. So you draw this displacement diagram using a mini drafter in a drawing sheet.